Hello, my Griffins. Check it out. Solubility Guidelines and Precipitates Lab. I just call this Precipitates Lab. So we're going to use Table F. That's our background. It's all set up for you. Isn't that nice? Yo, hey. Hey. There you go. So check it. Purpose. We are going to be able to do double replacement reactions and predict precipitates. Got it? And procedure. The procedure for this lab is you're going to take each of these chemicals. I'll show you them more in depth in a second. You're going to take 5 drops of this guy. And you're going to run through the wall plate. 5 drops here, 5 drops here, 5 drops here. This guy. 5 drops here, 5 drops here, 5 drops here. You getting a feel for this yet? And this guy. 5 drops here, 5 drops here, 5 drops here. And I lined them up in like this for a reason. This guy. 5 drops this way now. 5 drops in each one in this way. This guy over here, 5 drops and a third one down, okay? And then this is where we're gonna use to predict our precipitate. So this is the piece you gotta do first before I let you do the lab. But what you need to do before you do that is, you need to start to fill out this experimental data table, much like you see with the chemicals. So the chemicals in order, 3 of them. 1, 2, 3. Here's your close look. I got PbNO3, write that down. NaNO3 and AgNO3. All of those different nitrates need to go here. Okay? And then up top we've got copper sulfate, sodium hydroxide, and copper chloride. Now you don't need the names, you need the formulas, and those are going to go across the top. And I would label these are your 9 data boxes. I would label them 1, 2, 3, or your choice 1, 2, 3, but you gotta label all 9 of them. And this is why. Box 1 will be this chemical combined with this chemical. Bam. And if this is your box 2, then it's this chemical combined with this chemical. And that's where your reaction's gonna happen. In this box, after you number them in the corner small, when you actually do the lab, this is where you're going to write, yes, I saw a precipitate, or no, I did not see a precipitate. And that's your data, just yes or no. Now this box 1, well, let's skip to box 5, because that's on this page. I don't got to do a lot of flipping around. So this would be box 5, okay? Either way I number it, this is going to end up being box 5. So it's going to be this chemical plus this chemical. You're going to take your 2 starting chemicals. They're going to be right here. Those are my 2 reactants. You're going to perform the double replacement first. Remember, it always goes plus, minus from here. So plus, minus, plus, and then that minus. Bang, bang. Then you're going to use table F. Predict using the negative species whether or not this particular one will form a precipitate or this particular one will form a precipitate. You're going to predict ahead of time. And here's where the typo is from me. I forgot to label this up the way we learned it in class. So you should cross S off, or cross S to be insoluble, not soluble, and write AQ if soluble. Or cross off the S, better yet. Make this AQ for soluble, and then S for insoluble, forms a solid. If you want to leave it like this, it was my mistake, I'll let it slide. But otherwise, make this AQ, make this S. Make sense? Okay, good. So you're going to do that for all 9 reactions. When you've completed all 9 reactions and then predicted which ones are going to precipitate and which ones are not, then you can come and do the chemicals and follow the procedure that I showed you. 5 drops all the way across, 5 drops all the way across, 5 drops all the way across. Okay? After that, you're on to your claim, evidence, interpretation. Restate the purpose. Claim. Pick one that made a precipitate. When I reacted this chemical with this chemical, I created this and this. This particular one was the precipitate. I know it was accurate because what did you see in the well plate? And then your interpretation is going to go specifically, need the word solubility or insolubility, and use evidence from table F. So all hydroxides are insoluble except when they're with group 1 ions. My hydroxide was not with a group 1 ion, therefore it was insoluble. Some kind of a statement like that. Last piece, safety. Ready? AgNO3. This stuff, you can see it's starting to kind of turn in the Erlenmeyer. This will burn you. Don't get this liquid on you. It won't burn you like you know what I mean. It won't hurt. You won't feel any heat. Your skin ain't gonna bubble up. But you're in Rochester. It might take a few days, and then all of a sudden, everybody in school will know that you are burned. So let's not get this one on us, okay? Otherwise, it's something to be fearful of. I burned myself with this probably about 30 times working at Kodak. I'm still here. It's not gonna hurt you, but I don't want you to do it anyway. So there's how you do the Precip Lab. A lot of legwork up front, filling in these chemicals in the right place in your data chart, and then taking reaction one. Oh, that's going to be this chemical plus this chemical. Figure out what the products are going to be. Figure out if they're going to precipitate or not. Do all that legwork up front, and then the actual lab piece is easy. Of course, when we're done, you're going to come over to the sink. You're going to dump your stuff into the waste, and then you're going to take the little rinsey bottle, and you're going to rinse it into there, rinse it into there a few times, and then leave it over here somewhere upside down drying for the next group. Okay? All right, see you tomorrow.